Hello everybody, my name is Lane Nelson, and today we're going to be talking about direct measurement processing, filtering, and routing, which is included in the Meter Solution Cloud Service, the Customer Cloud Service, and the Advanced Meter Solution on-prem. It's included in version 2.4. Thank you for joining. On the agenda today, we're going to talk about the benefits of direct measurement processing and how to set it up. Thanks for joining. Let's start with the benefits and features of direct measurement processing. Let's start with direct measurement processing. And the goal of direct measurement processing, also known as DMP, is to reduce measurement database storage and provide higher throughput. Features include a service that inputs reads directly into the final measurement table, allows VE to run without creating initial measurement data staging records, and only creates IMD records if there is an exception. It reduces the size of the IMD staging table, which could be terabytes, and provides improved functionality for frequent read acquisition and event-based processing. So as you start getting more and more frequent data acquisitions, this is the solution you want to use. This replaces the IMD batch job. So think of it as a service replacing that D1 IMD batch job. The benefits are quicker processing and faster access to data, reduce application cores, meaning less risk of needing more batch streams, greatly reduces storage cost. And we're seeing like a 37% reduction in storage in our test, and a much higher throughput, like 70% higher throughput than conventional batch jobs. An important note, this feature requires the use of SGG native adapters, so you have to be using those to take advantage of this. Direct measurement processing functionally is doing the same thing as the D1 IMD batch control, but it's much faster. This is because there are fewer database inserts and updates, resulting in about 70% higher throughput. And since we are not creating IMDs for measurements that pass VE, the overall database is reduced by about 37%. For many customers, this will be terabytes of storage savings. DMP is only used for measurements coming from a head end, so it is not used for manual reads or system-generated measurements. These will use the traditional IMD process, and these are low volume, so this is not an issue. And please note, this will only work on new data. Older IMD data will need to be dropped using ILM partitions and database tools. Now let's talk about measurement, routing, and filtering that comes with direct measurement processing. It provides advanced filtering beyond just unit of measure to ignore unwanted readings. We've had the capability to filter out by unit of measure for a long time for channels of data you no longer want to import. But now we provide flexibility so you can do it for channels that have the same unit of measure, but perhaps a different service quantity identifier. This could be solar generation. Some customers have turned on solar channels for all of their meters, but they have very few customers that are with solar data coming in as generated data. They're filling up their database with zero generation reads. This enhancement will filter out those KWH generation reads via MC type configuration. It allows projects to route select measurements to cheaper storage also. So the benefits are provides flexibility, enabling projects to decide if reads are stored in MDM, ignored, or routed to other applications. It also saves storage by filtering out those unwanted reads, such as solar generation zero reads, and sending measurements to other systems like data lakes with more affordable non-OLTP storage. We keep data in Exadata very frequently, which is more expensive than cheaper data lake storage. This feature does require the use of direct measurement processing. Now on the right, we have a flow chart. Let's quickly go over that. We get reads into MDM SGG from the head-end system. We standardize those reads into the MDM format using our transformation layer, and we also standardize interval data codes that the customer is using. We filter out reads that are not needed. We then check to see if pre-VE data needs to be sent to another system like a data lake or our own EWDI. If so, we route the data to a directory or Oracle Object Storage if you're using OCI SAS or PAS. If the pre-VE data is not routed, we process it in MDM, doing our normal billing settlement processes. Now let's talk about how to configure direct measurement processing. Let's talk about demo data configuration. So the following presentation includes screenshots from the C2M demo database. Projects should have a copy of this demo database to refer to for configuration examples, like how we set it up and how we expect it to run. Now, if you want information about the scenarios, and we have two scenarios. One is Diane Mary Porter, which is meter ER SM399. It includes DMP, measurement replacement, a rich scenario. We also have Michael Paul David, which is ER SM1581, which includes DMP exceptions and filtering. So if you go to the extendable lookup and you look for the demo scenarios catalog and you look at these records, you notice we have an explanation that includes the scenario description, usage dates to search for, and important things to note. And all of our demo scenarios have records like this. So if you didn't know, this is a great resource for how do I go set up X, and you look for a demo scenario with that description and it will help you. Now let's talk about IMD types. Please go into the application and review the head and system provided IMD types. IMD types are configuration records used to define how initial measurements are processed using direct measurement processing. IMD types contain the logic for validating and processing reads, and the types include algorithms required to process reads like pre and post VE algorithms, as well as validation algorithms. Now let's talk about setting up the headed system. Please note IMD types are required for direct measurement processing to work. And as you know, you have to use the native SGG adapters. Make sure that you use the head-end system IMD type provided for each native adapter. When setting up your head-end system, please make sure filtered and pass-through data has unique MC types. Also, ensure you're using the correct head-end system IMD types as shown here. Make sure all UOMs are configured for your head-end system or you will definitely get an error. For measuring components you wish to route to other systems, make sure your MC types have pass-through turned on and the measuring component class is set to external. Pass-through reads are not stored in the MDM but sent to another system, and these pre-VE reads are exported as an XML file and sent to a location specified on the batch control. MC types for filtering. For device channels you wish to filter, make sure your MC types have filtering turned on and the measuring component class is set to external. Please note, filtered out reads are not stored in MDM. Make sure your devices have the correct head-end system configured. Add SGG payload processing configuration. Go to Extendable Lookups and add or edit an SGG payload processing configuration. Make sure you have a configuration value and you are using the SGG payload handler class as shown here. Make sure you also have the IMD type selected and your payload processing results are initial measurements and device events. You will need to set up object storage or file system locations. Go to Extendable Lookups and search for F1 file storage. Create a file location shortcut based on where your data will be retrieved and stored from. Remember the shortcut value you specify, you will need this later. You will specifically specify a server directory or object storage path. If you're running direct measurement processing only without routing, you can use the D1/PLPRM batch job. Notice the file locations use the file location shortcut created on the previous slide. Also notice the SGG processing configuration value you created. This is a typical view of channels on a device. One, we have the primary interval KWH channel coming into MDM for typical MDM operations, such as billing and other processes. Two, we have an external channel that shows data being routed out of MDM. These external records are not stored in MDM. Now, filtered data would also be an external channel and would look very similar, but it should be labeled filtered. Remember with DMP, IMD records are only created when there's an exception. However, if there is not an exception, we will still show a curve on the IMD overlay zone. We'll show the final read values. So when you go to the zone, you don't see a blank screen. And here's an example. Now, running batch jobs for DMP with routing. So if you're running DMP with routing, use the D1PLP SO batch job. And here are the typical parameters you would use. And please note, you need to use the SGG processing configuration you set up earlier. Payload processing shows external read processing. Users can look at the payload processing activity to see data that's been filtered out or routed to another system. To see this, go to the activity menu, use the activity query, and search for payload statistics. And here we have examples of pass-through or routed counts and filtered out counts for files that were processed. Thank you for your time.